Dear colleagues, please write or tell maybe. Can you hear me? Dear colleagues, can you hear me?
Yeah, we hear you.
Okay, I welcome you to the first international. Okay, dear colleagues, I welcome you to the first international workshop on computer information technologies. My name is Vasil Duzovsky. The organizers of the workshop are Professor Pavlo Marushchak and Professor Andrei Sverstyuk. We obtained approximately 60 papers and only 20 various publications. And today we have 13 papers. And during the workshop, kinds are possible in accordance with the situation in Ukraine. In particular, in the case of air alarms, there will be the breaks and continuation of the workshop after the air alarms. Let me to begin this workshop. And the first report fire safety monitoring system based on Internet of Things, authored by Andrei Polomov and Mikhail Polomov. So please.
Good morning. Let me upload my presentation. Can you hear me well?
Yes, we can.
Okay, thank you.
Please start.
My greetings, dear participants of the conference. My name is Andrei Polomar, and I'd like to represent the result of our research on a topic, fire safety monitoring system based on Internet of Things. The increasing prevalence of fire incidents and their devastating consequences highlight the critical needs for advanced fire safety monitoring systems. Nowadays, populated areas are harmed due to the bombarding because of the war in Ukraine, which leads to explosions, fire, infrastructure destruction, and fires. Fire accidents can cause severe damage to property and lead loss of life, and so it is crucial to have a reliable fire safety monitoring system. The literature review and analysis the topic revealed that the existing fire safety monitoring systems still have a number of limitations and disadvantages. Traditional fire detection methods and means, although effective to some extent, often fall short in providing timely and accurate information for effective emergency response. Hence, further research is needed to optimize the design of such systems and address challenges such as scalability, cost effectiveness, and ability of fire safety monitoring system in real time. The objective of this research is develop a fire safety monitoring system that addresses the limitation of traditional fire detection methods. This paper aims to design the implementation of a cost-effective fire detection system based on Internet of Things in order to provide real-time monitoring, data analysis, and prompt alerts in the event of a fire, which is a crucial aspect of fire safety. The proposed system architecture for fire safety monitoring based on the IoT concept is shown in this figure. It consists of a smoke sensor, a carbon monoxide sensor, temperature sensor, flame sensor, a microcontroller, a Wi-Fi module, a relay which can control fire extinguishing means, sound, and light alarms. The control model structural diagram of the fire safety monitoring system is shown in this figure. This diagram includes the following components like MQ2 smoke sensor, carbon monoxide sensor, MQ7, temperature sensor LM35, flame sensor. The main components of such system is Arduino Nano module, which is responsible for managing all the devices of the system. Wi-Fi module, Node MCU SP8266, and some actuators like relay, buzzer, and LED. The electrical schematic diagram of the control module for the fire safety monitoring system is shown in this figure. To develop software for the microcontroller, which serves as the core of Arduino Nano module, the programming language processing and Arduino IDE was used in this project. It received a remote notification about the fire safety status that if this then that service or platform was chosen, which allows creating specific triggers and corresponding conditions to ensure task execution on compatible devices. Source code listing of the function which is responsible for sending data to the if this and that service using an HTTP protocol is shown in this figure. Once the hardware and software components were developed, they were integrated to form of a complete fire safety monitoring system prototype. A series of testing procedures were conducted to evaluate the functionality, accuracy, and reliability of the prototype. It was also tested for its compatibility with the if TTT service, ensuring successful communication and seamless integration. On this figure shows the example of incoming OIP call in the EFTTT application caused by an alarm of signal generated by the control model of fire safety monitoring systems. Let me now come to some conclusions. In this paper, the design and implementation of fire safety monitoring system based on IoT was presented. The study shows that the IoT-based fire safety monitoring system has several advantages over traditional fire monitoring systems, including the ability to collect and process large amount of data in real time, integrate with other devices, and take prompt actions in the event of a fire. The scientific overall, the designed IoT-based fire monitoring system has great potential to improve fire safety and reduce the damage caused by fires. Thank you for your attention. If you have any questions, I will be glad to answer them.
Thank you for your report. So, dear colleagues, maybe someone has questions. Please ask.
Good afternoon. Good afternoon. Yes, I have one question for Andrei Palomar. Irina Belyakova, candidate of Engineering Science, Department of Electrical Engineering. And I have one question for Andrei. Maybe you know, have similar research been done in our country in this term, in this problem?
Yes, I thank you for your question, and we have conducted deep literature review on the topic, and there are several studies, several research, including in our country also, was conducted, and they was try these researchers was also try to use some specific designs and some specific solutions, like using GSM modeler to send some data, some notification to the phone, but this has some advantages and disadvantages, and our solution is different.
Okay, thank you so much.
Thank you.
Thank you. Any other questions? Okay, so let's continue. And next report is method, algorithm, and computer tool for synfast detection of radio signals in telecommunication networks with noises, authored by Lila Khvostivska, Mykola Khvostivsky, Irina Degi, Vasil Yatsky, and Yuri Palenitsa. Please.
Good day. Do you hear me? I can start screen share because the before presentation is not closed. Please close the presentation. Good day, dear colleagues. I would like to present a report on the topic method, algorithm, and computer tool for synfast detection of radio signals in telecommunication networks with noises. The authors of this research are Lilia Khvostivska, Mykola Khvostivsky, Irina Degi, Vasil Yatsky, and Yuri Palenitsa. No algorithms for processing radio signals for their detection of useful component in telecommunication networks with interference are implemented using filtering methods, the core of which are mathematical models of types of random stationary process and the sum of useful signals and noise. The specified source of models are idealized through their constructive consideration of only stochastic components without combining them with a periodic component as the main feature of real radio signals with various types of modulation in telecommunication network. Therefore, the use all periodically correlated stochastic process arsenal for the development of a new method, algorithm, and computer tool for processing radio signals for their detection in telecommunication network with interference is actually a problem. In the development process, the telecommunications network is the most vulnerable link that is affected by disturbance of various power. Figure 1. The experimental implementation of radio signal, in particular on the example of an amplitude modulated signal, is shown in figure 2. All modulated radio signals in the process of their transmission are characterized by indicators of stochasticity and periodicity, which are through the influence of interference and the harmonic component in the modulation of radio signals. Radio signals in telecommunication networks with interference are represented as a periodically correlated stochastic process in the form of an expression 1. Synfast processing of the radio signal provides the process of estimating the correlation components, take it into account covariance statistics, expression 2. Figure 3 shows the structural sequence of the research process of detecting useful radio signals in telecommunication networks with noises. The structural elements of the sequence are as follows. Synfast processing of radio signals in telecommunication networks with noises according to expression 3, which calculates the detection rate in the form of correlation components. Evolution of the calculated correlation components according to the form and values of which will ensure the process of detecting radio signals. Making a decision based on the form and indicators of the statement correlation components regarding the presence or absence of useful radio signals in telecommunication networks with noises. The algorithm for Synfast radio signal processing in telecommunication networks with noises is shown in figure 4. The result of Synfast detection of radio signals in telecommunication networks with noises in the form of calculated correlation components with the interference power level is shown in the form of a 3D implementation in figure 5. The level of noises dispersion increased by 0.3 V squared, and the result of the calculated components of the radio signal at this level of noises is shown in figure 6. The level of harmful dispersion was increased to 1.2 V squared, which exists the level of the most useful radio signal, and the components shown in figure 7 were calculated. For a more detailed evolution of the calculated correlation components, the average evolution by components was used as suggested by Mykola Fustivsky. The result of averaging the components of the radio signal at different levels of noise dispersion is shown in figure 8. The estimated components through their averaging make it possible to compare the detection result in more detail than in the case of non-average components, which ensures the process of effective and reliable detection of radio signals in telecommunication networks with noises. Using MATLAB Guide, a computer tool with graphic interference was developed to detect useful radio signals in telecommunication network with noises. Figure 9. The implemented computer tool provides a procedure for automatic synfase detection of usable radio signal in telecommunication network with noises of detective power. The results of processing radio signals as a predictably correlated stochastic processes in telecommunication networks with noises in the form of average correlation components states that the developed synfase method, algorithm and computer tool organize the process of tracking and synfase detection of the presence of a useful radio signal component against the background of noises of different power. This fact indicates the effectiveness of the process of detecting useful radio signals as a predictably correlated stochastic processes when using the synfase method. Thank you for your attention.
Thank you very much for your report. So, dear colleagues, please, maybe you'll have some questions. Please ask. I'm sorry, Natalia Kuzenko, we can't hear you.
Oh, I don't.
Yes, we can. Now you can.
Yeah, you can. Okay. The question is such: can you tell me what are the advantages of your model compared to another models? I think that it's not only one model of such process. Please, what are the advantages?
This model take into account periodicity of the signal, of radio signals. And other models, known models, don't take into account periodicity of radio signal.
Okay, thank you.
I'm sorry. Any questions? No questions. So thank you for your report. And next report is information system for adsorption parameters identification in nanoporous media. Authors are Mikhailo Patrick, Dmitro Mikhalik, Jacques Frassard, and Oksana Patrick. So please.
Yeah, morning, dear colleagues. So let me share my screen and I will start the presentation. So as was presented, the topic is information system for the absorption parameters identification in nanoparse. It was done in collaboration between the team of scientists of the Grenoble National University and our colleagues in the Sorbonne University, France. So it's well known that scientists utilize mathematical models to study the complex physical objects to take the benefits of math and computer science. And our team have actually the history and the bunch of the researchers made for these topics. And the goal of the current research was to actually combine the mathematical model, the theory of optimal control, and the benefits or advantages of the software engineering to build the information system for the absorption parameter identification. So let me start from the ground, and actually in the core of our research is a mathematical model. And we believe that the diffusion process can be described as a system of two partial equations. Actually, first equation is the relation of the concentration in the infraparticle space, and the second one is the concentration inside the small particles, which have the small parts as well and keep the mass too. So as these equations are accomplished by the initial conditions, the boundary conditions, and in case of the heterogeneous media, which could have a different pitches in different parts of the media, we could have the contact conditions which actually allow us to define this heterogeneous nature of most of the real materials. So the second part is actually how we can build a solution of this model. So one of the proposals is to apply the numerical solutions and use the Krohn-Nicholson schema to do that. And we split actually our area or domain of the functions into the small part, actually into the three directions, the direction for this, the x and the time. And after the transformations of initial mathematical model using the Krohn-Nicholson schema, we obtained the equations 7 and 8. And the orthogonal grid looks like the following. Having this in mind and doing some algebraic, some transformations or manipulations, we came to the equation 9 and 10, which actually is the linear equations, which can be combined into the system, and actually applying the iterative process of Thomas algorithm to the system allow us to determine the concentrations in intraparticle and extraparticle spaces at the next level, time level, using the information from the previous levels. Actually, we apply it iterationally and build the cube of the values. Now, going to the next part is actually experimental studies, and our partners in the Sorbonne, they actually did the experiments, the real experiments on the real materials with the equipment, and collect concentrations for the hexane and benzene extraction on this zeolite DSM-5. Unfortunately, this experiment is quite expensive, and they can't apply them or repeat them very frequently, so they can do only some of them. And it's actually our main goal to get the most from this experiment and to be able to share this information on other researchers. So actually, our idea was to use the experiment studies in combination with the mathematical model and numerical solution of this model, and try to identify the kinetic features of this process, which can be multiply reused in different numerical simulations. So what we did, we actually take the ideas from this theory of optimal control and use the gradient method to identify the distribution of diffusion coefficients. According to this method, the followed gradient identification procedure is used to determine the next approximation of the diffusion coefficient. So I mean, by next, it's the next step because it's iteration process. And we repeat it again and again till we not get the sufficient difference between what we predict with what is real. And in that, when we stopped, and actually we can tell that, okay, we identify the coefficient with such precision. And actually the function residual determines the deviation of the desired solution of its traces. Having that, actually we create the software and did the diffusion coefficient identification using the proposed method, and the second on the left is actually we using the obtained coefficients, we simulate absorption curve and compare it with the experiments, and as you can see, it's pretty much correlated. So there are two graphs, 1 and 2, and they're very close to each other. This means that our coefficients was identified pretty precise, and it allows us to recreate the mass curve with the same precision. Also, during doing these experiments, we did it for different points of times. Actually, how it was strictly connected to the experimental studies that we get as the inputs, and there are a lot of different insights we found, but one of the insights actually it's related to the diffusion coefficients evolution. And what we can see is that these coefficients, they not only have different values moving from the top to the bottom of the media, but itself they vary in time. So when we take different process times, the first example is the initial phase of the diffusion process when the zeolite is full of gas. And moving forward till we reach the state of the equilibrium, we see that the coefficients also not stable and they change in values. So what we see is that coefficients both have different values for different parts of the zeolite, and also they evolve during the process itself. And the conclusion and the information system for identifying and studying parameters of complex absorption and diffusion processes in heterogeneous media of microporous particles has been implemented. The direct and conjugate problems of coefficient identification in intraparticle space are formulated, and the identification algorithm of kinetic parameters using the gradient methods and numerical solution was built. The adequacy of the results obtained from the identification process was validated against the experimental observations. Furthermore, the numerical solution and analysis of the kinetics of absorptions, as well as the concentration gradient fields, was conducted. The results of the study enable efficient simulation of absorption process kinetics and can be further utilized for the exploration of the equilibrium conditions in complex systems under the influence of various factors. That's it from my side. Feel free to ask any questions. I will be glad to answer. Thank you.
Thank you very much for your report. So, dear colleagues, please ask your questions, if any. Okay, so thank you again. And the next report is visualization of the structure of DCT based on a synthesized algorithm using cyclic convolutions, authored by Igor Provodsko, Yuri Bilas, and Vasil Teslyuk. So please, you're welcome.
Good day. The name of my work, visualization of the structure of DCT based on the synthesized algorithm using cyclic convolution. Affiliation of the authors is Lviv Polytechnical National University. The various of efficient algorithms have been developed for computing discrete transform of Fourier class. This is defined in the matrix form, where W can be a basis square matrix of discrete Fourier transform, discrete cosine or sine transform, or discrete Hartley transform. These fast algorithms are used to represent information data in a spectral image and are applied in information technologies for various purposes. There are 8 types of DCT which are widely used in processing of digital audio and video signals. Direct DCT of type 2, and simply called DCT, can be represented by the formula. The efficient computation DCT is divided into algorithms with a base of 2, split base, odd size, and as. One of the approach of efficient computation DCT uses the cyclic convolution. The use of cyclic correlation structure provides high computing speed, low computational complexity, and low input-output bandwidth. It reduces the hardware cost. The result of the synthesis of computational algorithms needs the interpretation, not only in the form of formulas or flowcharts, but also in general computational structure form. The proposed approach of the fast algorithm synthesis using cyclic convolution is to lead efficient conversation, the basic of arbitrary size of DCT, into block cyclic structure. This structure of basis matrix can be described by hashing array, where integer element of hashing array are arguments of the basic harmonic function. The Hessian array is determined by substituting the columns of the arguments of the basis harmonic function of DCT base matrix. The properties of periodicity, symmetry, and asymmetry of the basis function lead to the representation of smaller value of arguments of basis. The simplified matrix of arguments is DCT is complemented by the matrices of cosine signs. For the indexing base matrix, the Hessian array row and Hessian array column are used because of the different expression of column and row indices included in the arguments of the basic function. For the synthesizes of fast DCT algorithm, it is necessary to analyze the structure of the obtained block cyclic matrix in order to determine identical blocks placed horizontally and vertically relative to each other. This reduces the number of computations of convolution cyclic. On the example of the synthesis of fast DCT algorithm for size 27, the Hessian array contains the following elements: Hessian array of rows, Hessian array of columns. In the result of the reindexing, the block cyclic structure of arguments of DCT is presented on the feature. As a result of the analysis, the block cyclic structure of base matrix, we obtain the described the convolution in the form on example of DCT for size 27, an example of TXT file where denote cyclic convolution. We have this data text file contains the minimum number of cyclic convolution. Input data must be previously element-wise combined. The structure rendering software implementation of VCT based on Colvorwith uses types programming language. Framework phrase 3 was chosen as visualization tool. The program for processing the description TXT file of fast algorithm uses modulus, tokenizer, parser, optimizer. The visualizer module provides imaginary of the structural scheme of VCT. For this, a simple linear sequence steps is performed. Interaction with the system is carried out the user interface, in which settings are made to display the structural scheme of the VCT. As a result, we get a display of the system on the screen and download image into PNG files. That will be contain the structural scheme of the VCT or part of it. The image computational structure of VCT for size 27 using singulation is presented in the, we can see unit of cyclic convolution 9.3.1. Element-wise combined unit input data and element-wise combined unit of results of cyclic convolution. Scientific novelty of obtained results lies in implementation, the visualization of the computational structure of discrete cosine transform, as created description of the synthesized algorithm, which includes multi-level sets of cyclic convolution. The practical significance of the work lies in the fact that the obtained results of visualization of the computer structural schemes of DCT for specific size of transform is important for the system engineering stage of designing VCT based on cyclic convolution, because clearly reflected the general interaction of its parts on algorithmic levels. Prospects for further research are the development and implementation CAD system for designs the computational structure of DCT using low complexity convolutional formulation. Thank you for attention.
Thank you very much for your report. Dear colleagues, maybe you'll have some questions. Please ask.
Okay, I have the question.
You're welcome.
You
Please.
hear me? Okay, thank you. Can you tell me a few words about the application of your model? Thank you.
My model has a wide application in different regions, especially in signal and video processing and other applied regions.
Thanks.
Thank you. Many other, maybe other questions, dear colleagues? No, so thank you very much. Thank you for your report. And the next report is an autonomous service physiological logic-based decision support system for evaluation of the reliability of a country's electric power system, authored by Bogdan Zimchenko and Anatoly Melnik. So please. I'm sorry, we can't hear you. Sorry, but we can.
Now you
Oh,
hear
yeah,
me.
yes, now we can hear you.
Sorry again. Greetings everyone again. I am delighted to present our work titled An Autonomous Serverless Fuzzy Logic-Based Decision Support System for Evaluating the Reliability of a Country's Electric Power System, authored by the Professor Anatoly Melnik and me, Bogdan Zimchenko. Let's commence by understanding the broader context. Electric power systems, the lifelines of modern societies, are exceptionally complex. With a multitude of interdependencies and variable conditions, managing these systems and evaluating their reliability becomes challenging. Numerous factors can influence the trustworthiness of energy provisioning systems, such as energy production, usage patterns, climatic conditions, upkeep level, human errors, and constraints in the transmission network. A thorough evaluation method that considers each of these aspects is required to effectively assess the reliability of EPS. Our research hence serves as a vital leap forward. We've designed a solution to ensure a more resilient power infrastructure for country. Microsoft Azure Cloud Infrastructure, Azure offers many benefits that align with our goal to assess the dependability of electric power system using a decision support system or DSS. This includes scalability, cost efficiency, high availability, and robust security. Our Azure-based DSS structure has key components: API gateway, controls, secures, monitors AP functions, safeguarding that data integrity, receiver function. It's an HTTP-triggered Azure function, processes incoming data and deposits it into the service bus. Service bus is a message queue system, improving scalability and fault tolerance of the whole system. Fuzzy logic function, it extracts data from the service bus for processing using fuzzy logic techniques to calculate reliability indices. Cosmos DB, it stores calculated reliability indices, input data, and fuzzy rules, facilitating easy querying for analysis. And Azure Blob Storage stores initialized fuzzy inference module instance to improve system efficiency. And the API function, which fetches latest reliability data from Cosmos DB, providing an API for external access. Relational fuzzy DB database, the diagram of this shows how the data is stored. It is related to the fuzzy logic. The fuzzy logic area stable record has an area name property that corresponds to the topic area it solves. A term table record has a term name string property that represents a linguistic variable. A term table stores a set of linguistic variables for a particular subject. The sets table record has a key string property, which is the linguistic value. It can be applied to the corresponding linguistic variable, and its numeric value, which is the value double property. A rule table record has a rule value string property that represents a rule in a specified format using a linguistic variable and its corresponding linguistic value. Rules are defined as an if-then constructs. And the relational EPS reliability database stores country-specific and region-specific data, as well as EPS reliability values. This relation database is designed to accommodate a variety of geographical areas and their respective reliability values, thus allowing for a broader and detailed assessment. Let's delve into a fuzzy logic implementation. First of all, we start with defining linguistic variables for various parameters. This include power generation, power consumption, air temperature, sunlight intensity, maintenance status, and weather status, alongside an output variable for the reliability index. Once the linguistic variables are defined, the fuzzy rule base is created, and the fuzzy inference mechanism, which, as you remember, is a like Azure function, evaluates these rules which were defined to determine the degree of each rule's fulfillment. We use the centroid method for the defuzzification process, which calculates the crisp output value as the center of gravity of the fuzzy output set. This entire mechanism is implemented using the aforge.net framework. We've assessed the proposed system using simulated test data, mirroring real-world parameters like power generation, consumption, temperature, sunlight intensity, weather conditions. This test data, focusing on various regions in Ukraine, was developed using historical data, trend analysis, and statistical models. Upon generating this data, it's sent to the data receiver function for validation and transformation, then stored in the message queue. The fuzzy logic function retrieves and processes the data to compute the reliability index for different regions, which is stored then in the Cosmos DB. Users can access the most recent reliability data through the API function, enabling them to understand the reliability of the electrical system easily. Let's talk about results. We generated a heat map diagram displaying the EPS reliability rating for various regions throughout the day. This visual representation helps in identifying trends, patterns, potential concerns related to the EPS reliability, providing an intuitive tool for experts in the field. Looking forward, we aim to refine our fuzzy logic model by incorporating additional parameters and exploring machine learning techniques. We plan to develop a hybrid architecture addressing data privacy, security, and latency concerns. And importantly, we aspire to evaluate our system using real-world data, comparing it with traditional approaches for a robust analysis. Our autonomous serverless GSS on Azure offers scalability, flexibility, cost efficiency, removing the need for local hardware. It employs fuzzy logic for robust decision-making with uncertain inputs, ensuring reliable EPS evaluations. Integration with existing infrastructure is seamless, and Azure's security measures safeguard data. Our system supports continuous improvements and future enhancements. Research shows the framework's potential in reliable EPS assessments, with heatmap visualization providing clear regional insights. Our unique blend of serverless architecture and fuzzy logic marks a novel approach in EPS reliability assessment, but it's worth noting that model precision hinges on the quality of input data and the fuzzy rules themselves. Also, the cloud's reliance raises potential security concerns. So that's all. Thank you for your attention, and feel free to ask any questions.
Thank you very much for your report. Dear colleagues, please ask your questions, if any.
I have one question. So what's the source of your input data? You mentioned on your diagram you have the API gateway as the entry point. So someone's supposed to push the data to your system, or you pull the data from somewhere. As I assume it should be some kind of time series metrics.
Okay, let's go back to the architecture. Yeah. The data is pushed through the API gateway, but the source of data, the source of data is first of all historical data that can be found. For example, weather conditions, temperature, sunlight intensity also can be found through the internet to different regions in some like past timeline. Secondly, we analyze this data and create some simulated data based on historical data. After that we create model and just feed the system with all this data we have. But now I understand that it's very good question if we need machine learning. We plan to enhance it with machine learning techniques, and we need to collect more data, and it should be mostly real. So it is a challenge for now.
Okay, thank you.
Thank you.
Thank you. Maybe any other questions? Okay, so thank you very much for your report.
Thank you for
Next,
attention.
our report is optimization of schematic and technical tools for determination of spatial acoustic signal source location and the polygon given in the Hamming space. Authored by Bogdan Trembach, Rostislav Trembach, Mikhailo Palasyuk, Roman Kochin, and Volodymyr Salkiv. So please, dear speakers. Bogdan Trembach, are you here? Can you present your work? Oh, yes.
Yes, I'm here. Sorry,
Thank you.
I have some problem
So
with the presentation. Okay, so I would like to present our work related to the determination of the source of the acoustic signals using digital-based correlator system. So in general, the task of detection of the source of the acoustic signal is in to find the source in the Cartesian or the polar coordinate system, and an example is shown on the figure 1. So the idea is to find the square in the matrix of the Hamming space, which is on our coordinate system. And and we made some optimizations in our existing proposed system. And the first one is to select a basic distance between our microphones in the system that should be relevant to the speed of sound, and it helps us to reduce the hardware complexity of the calculations, and it could also speed up our calculation of the coordinates of the source of the signal. So the main idea was to create digital correlator that could actually take signals from the microphones and using the correlation functions to actually to calculate this, the coordinate of the source of the sound signal. And in our system, we are using substitution correlation method, and for which is the main idea of this method is to get the signals in time from for example 3 microphones in our system, and get the as you can see on this figure, we have one timeline where we measuring the signals on the microphones, and using correlation methods, we could actually calculate the time differences between the measurements of the our signal on the microphones. This time differences we are using to actually calculate the source of the acoustic signal. And so on this figure, showing the already proposed system to implement this our task, and in this work we are made some optimization with modular differential adder. This they are shown on figure. The modules 8 and 7. So to reduce the hardware, because we are using modular differential function, we were able to reduce the hardware complexity by creating specialized modular adder that could reduce our hardware complexity and increase the speed of the calculation of the correlation function. And as a so we were able to calculate hardware and time complexity, and we are able to reduce the hardware complexity to more than 2 times, and time complexity by from 3 by 4 times. It depends on the realization. So here you can see our final calculations, how many microducts needed in our system to actually calculate the source of the signal from the moment when we are receiving this signal in our system. Okay, so as a result, by implementing specialized hardware, we were able to reduce the hardware and time complexity of our device. And it gives us an opportunity to calculate the source of the acoustic signal faster than is an existing analog systems. That's all I have. Thank you for your attention, and if you have any questions, please feel free to ask.
Thank you for your report. And dear colleagues, please ask your questions, if any. No questions. So thank you against. And now we have to have a short break according to our program, workshop program. So let's make a short break and continue after it. Okay, dear colleagues, let's continue. And the next report is the methods of computer modeling of hard written based on the vector of stationary and stationary related random sequences, authored by Petro Onynsky, Yaroslav Litvinenko, Alexander Volyanik, Grigory Shimchuk, and Volodymyr Gutovich. So please.
Hello, can you hear me?
Yes, we can, please.
Do you see my screen? Yes, you see my screen.
Yes, we are.
So, my name is Volodymyr Gutovich. I work on the position of Associate Professor of Computer Science Department in Ternopil National Ivan Poliy Technical University, and let me present the main results of the research on the topic the method of computer modeling of hard rhythm based on the vector of stationary and stationary related random sequences. First of all, briefly about relevance of this research. Nowadays, there are a huge variety of automated diagnostic systems that allow studying the state of the human cardiovascular system. And of course, the effectiveness of such systems depends on their components, including hardware and software tools and mathematical models. Our article discusses a method of computer modeling of the rhythm of an electrocardiogram signal based on a mathematical model in the form of a vector of stationary correlated random sequences. Our computer modeling method allows for the formation of implementations of the vector rhythm of the cardio signal for different types of cardio signals, both in the norm and with different types of pathologies. As you can see, there is a huge variety of relevant scientific studies. However, rhythm analysis methods have been less widely applied since not all mathematical models take into account the stochasticity and variability of the rhythm. This is due to the insufficient level of development of mathematical models and methods of rhythm analysis. Main results of our research. In the scientific research number 7, rhythmocardiogram signal with increased resolution is substantiated, and authors of that research described this signal using a vector of stationary and stationary related random sequences. There is an expression of this vector. In our studies, we use expression 1. This is a mathematical model of the rhythmocardiogram signal with increased resolution in the form of a vector of stationary and stationary related random sequences. The authors of scientific research number 7 applied this model. In order to implement the task of modeling the ECG rhythm signal, we consider a 5-component vector, duration of the diagnostic zones of the electrocardiogram signal, and the model of which is a vector stationary associated random sequences. On the figure 1, you can see graphical presentation of fragments of the investigated electrocardiogram signal, ECG, realization, and discrete rhythm function for 6 cycles in the ECG. From the figures 2 and 3, you can see fragments of the implementations of some components of this vector, especially component 1, 2 and number 4. For data components of this vector of stationary related random sequences, we estimate correlation functions by using expression number 2. By using expression number 3, we estimate of mathematical expectations of each of 5 components of this vector. Fragments of realizations of estimates of the correlation functions of some components of this vector you can see on figures 4 and 5. On figures 6 and 7, you can see some results of computer simulation. Particularly, there are fragments of the simulated implementations of some components of the vector. Figures 8 and 9. Here you can see fragments of estimations of correlation functions of implementations of simulated components of our vector. In our study, we investigate the accuracy of proposed method of computer simulating. We determined the absolute and relative errors of modeling by using expression number 4. On figure 10, you can see graphical presentation of absolute and relative errors of computer modeling. Absolute and relative errors. Briefly about analysis of obtained results. The maximum relative error of modeling statistical estimates of vector components doesn't exceed 17%. In scientific researchers number 6 and 14, a structured diagram of a diagnostic complex is presented. We include in this diagram an additional block for computer modeling of a vector cardiac signal. Here, this additional block is highlighted by gray background color. And conclusion, brief, of course. In our study, we propose a method for computer modeling of the heart-rhythm electrocardiogram signal in the form of a vector of stationary linked random sequences. During the computer modeling of realizations of the vector cardiac rhythm signal components, obtained statistical estimates of the real ECG were used. And an assessment of the accuracy of the computer modeling of vector cardiac rhythm signal components was carried out, and it was established that the relative error of such computer simulating doesn't exceed 17%. Thank you very much for your attention.
Thank you for your report. So, dear colleagues, please ask your questions, if any.
Hello, can you hear me?
Yes, we can, please.
My name is Alexander Holtenko. I have problems with my camera in my phone. I have a question. Please tell me why do you use the five component vector, exactly 5 component vector?
5 components vector. Thank you very much for the question. Yes, I understand you mean such question, such formulas. Here we use 5 components vector because one period of ECG contains 5 diagnostic zones. Unfortunately, I don't have right now a good presentation of ECG one period. On this figure, you can see fragment. There are 6 periods.
Okay, thank you.
Thank you very much.
Thank you for your question. Maybe another questions? Okay, thank you very much for your report. And the next report is the method of command identification to voice control of the electric wheelchair, authored by Vasyl Dozorsky, Renat Dediv, Sofia Srstyuk, Vyacheslav Nikityuk, and Andrei Kornilko. I'll try to present this work. I'm sorry, one moment, please. Can you see my screen?
Yes.
Okay, so in the research, an attempt is being made to develop a prototype of the voice control system for an electric wheelchair. In particular, the development of algorithms for the operation of such a system and appropriate methods of processing voice signals to form the necessary command signals, taking into account non-standard and dangerous situations. The essence of the voice signals processing method for the selection of command words, and accordingly the functioning of control signals system based on them is reduced to the following. We need to recognize 4 commands in the voice signal: left, right, back, and forward. The work of the system was focused on the possibility of working with the Ukrainian language. At the first stage, the user speaks those words into the microphone. The information system processes them and selects informative scenes, which will be used to identify those commands in the next step. First, the signal is recorded, then it is filtered using adaptive methods. Next, the word length of each command is determined. At the next stage, each word is segmented into phonemes. Actually, on the last step, areas with signs of vowels and consonant vocalized sounds are determined. All 4 commands differ in their phonetic composition for Ukrainian language. The alternation of phonemes in commands is different too. Therefore, for phoneme segmentation, the value of main tone frequency, which is also one of the biometric characteristics of each person, is used as an informative thing. At the first stage, the time limits of each command are identified. For this, a sliding window is used within which the average value of a voice signal is calculated. Further, this value is compared with the threshold, and if it is equal to or exceeds the threshold, then the value of the threshold function is taken as 1, or size as 0. The algorithm of such processing is shown in figure 1a. At the next stage, the main tone frequency is determined, which is present in the vowels and consonant vocalized phonemes. For this, the method of Raman analysis was used when the main tone frequency corresponds to the frequency of the first maximum in a power spectrum. For this, the processing was also carried out using a sliding window, and the algorithm of such processing is shown in Figure 1b. And at the last stage, the command is identified. For this, the unknown command is processed within the sliding window as follows. The presence of the main tone frequency is assessed. It will be present only in the sections with the duration of the command that corresponds to vowels and consonant vocalized sounds. Further intervals with the presence of such a frequency are formed, and already by their segments and size, the command is identified. Since the sequences of those sections and durations must be different for the four considered commands. Having identified the commands, generating control signals is not a difficult task. The command recognition algorithm is shown in Figure 1c. A standard computer headset and the Adobe Audition environment were used to select voice signals, to record such signals with spoken commands. It's shown in Figure 2. Further, the signal was loaded into the MATLAB environment in which its further processing was carried out. The appearance of such a signal is shown in this picture, in Figure 3, sorry. According to the algorithm, the duration of each command is determined. The view of the value of a threshold function is shown in Figure 4. At the last stage, phonemic segmentation of each individual command was carried out. In Figure 5a, the appearance of a voice signal of the first command is shown. Further, the estimates of a spectrum were constructed, and its averaging was carried out within the limits of the sliding window. If the main tone frequency was present within these limits, it was manifested in a signal spectrum. Those averaged spectrum values around the main tone frequency were plotted on the same time axis according to where the sliding window was placed. The resulting graph is shown in Figure 5b. Next, a threshold function was constructed with a threshold of 0.1, which was chosen a priori. Its appearance is shown in Figure 5c. In addition, analyzing in Figures 6, 5, 7, and 8 shows the view of a signal of the next three commands, the graphs of the main tone frequency presence in the signals, and the view of the threshold functions. In addition, analyzing the given graphs for four commands, we can come to the conclusion that based on the values of the threshold function and the duration of the commands, their identification and the subsequent formation of the corresponding control signals can be carried out. In order for the system not to be sensitive to similar commands that can be uttered by the person in a context of a conversation, it is suggested to use a certain keyword, after the appearance of which the command word must be followed. Also, the second keyword will mean the end of the command. Those keywords can be selected by a system user individually, but with the lowest possible frequency of occurrence in a speech of the user himself. Thank you for your attention. So please, maybe you have some questions. Okay, thank you. And the next report is designing and implementing intelligent lighting control systems, authored by Vadim Koval, Serhiy Marchenko, and Miroslav Zin.
presentation on designing and implementing intelligent lighting control system. Smart lighting is one of the key control components in the smart house intelligent system. Its main task is to provide comfortable conditions for people and reduce their role in managing process in the home. Light sources are the object of control in smart lighting. Currently, there are mainly two types of light sources used in residential and office buildings. LED lamps prevail in residential buildings and fluorescent lamps in office buildings. Intelligent lighting control system use two main methods to reduce energy consumption. The first is to adjust the brightness of light sources. The second is switching off lighting in places where people are not present. Lighting level sensors are most often used to control the brightness of light sources. In the second case, motion or presence sensors are used. The combination of these two methods provides a significant energy-saving effects. In intelligent lighting control system that operates in rooms with dynamic lighting, light sources can be in frequent switching on-off modes. In this case, the transient processes that occur when they are switched on and the reaction of people to switching on the lighting should be taken into account. If the switching on process parameters are correctly selected, people will feel comfortable and the light sources will last longer. However, there are currently no clear recommendations for intelligent dynamic lighting control system that take into account the physical processes in light sources, human physiology, and lighting quality that doesn't cause discomfort to people. The use of fluorescent lamps in lighting system with a control system faces a number of challenges. One of them is the short-term preheating of the lamp electrodes before switching on. Its presence creates a delay before switching on. This should be taken into account when designing intelligent lighting control system. Therefore, experimental studies were carried out to determine the duration of the preheating mode of fluorescent lamp electrodes. The studied lamps were switched on in accordance with the scheme which you can see in this slide. A measuring information system based on a personal computer with an analog to digital converter module was also used to obtain oscillograms of the transient processes. From the oscillograms, the duration of the transient process was determined. In this slide show the measurement results. They are present in the form of a table. As a result of the generalization and processing of this data, their approximation was carried out. An analytical formula was obtained that makes it possible to calculate the transient time of various fluorescent lamps of any power. Taking into account this data, the limiting frequency with which the lamp can be switched on, so that the light from it is perceived by a person as separate flashes is established. It is determined by the formula present in this slide. When using LED luminaries in dynamic mode in an intelligent lighting control system, two main problems arise. The first is their high brightness. The second is that people feel discomfort when the light is switching on. These statements were confirmed by experimental studies. to study the operation of light sources in lighting systems with an intelligent control system. An experimental lighting system was made. It operates on the basis of Atmega microcontroller and is located in 35 meters long corridor. In this experiment, linear LED lamps were studied. This corridor situated in our university. The lighting is switched on based on signals from sensors when a person appears in the area of their action. The lights are switched off after a time delay, provided that there are no people in the area of motion detection. This lighting system implements a dynamic lighting control algorithm. When a person is detected by the motion sensor, a signal is sent to the microcontroller. The motion sensor is bidirectional and detects the movement of people both towards and away from the luminary. This makes it possible to determine the direction of human movement. Based on the sensor's signals, the microcontroller switched on the corresponding luminaries. In this slide shows a lighting system with LED lamps which switches on. About the experiment. In a survey of students, 98% of them were negative about the dynamic lighting mode. The main comment was about discomfort when switching on the lamps. Therefore, it was decided to use a smooth switching on the lamps. However, the time of the smooth switching on remained unknown. The smooth switched on time depends on the following factors. When a person moves along the corridor, the time of the lamp brightness to increase should be no more than the time from the moment when signal is received from the motion sensor to the moment the person approaches the illumination zone, and also not be less than the reaction and adaptation time of the human eye. Since these data are individual for each person, we conducted two field experiment. During the week, a specific soft start time is programmed to each day. It has been set to be the same through the day. For example, in Tuesday it was 1 second, for Wednesday it was 2 seconds, and so on. At the end of the day, the same responders were surveyed about the comfort, the quality of the dynamic lighting system. The questionnaire contained only one question: is it comfortable to walk along the corridor with these lightings? The expected answer was yes or no. A total of 86 students and teachers took part in this survey. The results of the survey are shown in this video. As can be seen from the survey results, the most positive response was given to the switch on time of 3 seconds. However, in the case of rooms where the speed of movement of people will be higher, the switch on time can be reduced to 2 seconds. So in last slide summaries the main conclusions. Thank you for your attention.
Okay, and the next report is cybersecurity assessments based on combining PD method and stride model for learning management systems, authored by Taras Lechachenko, Tomasz Grakanjuk, Taras Lober, and Andrei Postolyuk. So please.
Give me a few minutes. I'm tune my presentation, and then I will be ready to. Does the slide move?
Yes, they are.
Okay. Dear guest and conference participant, allow me to present the publication Cybersecurity Assessment based on combining TODI method and STRIDE model for learning management system. The issue of security in learning management system requires particular attention, as these systems are instrumental in training future professionals, including those in the field of cybersecurity. In some cases, learning management system can be seen as operating within interdisciplinary cyberspace. This is due to the involvement of the stakeholders who participate in the preparation of specialists through these software solutions. These stakeholders include not only educational institutions, but also employers, as they contribute to curriculum development and serve as practice bases and providers of educational courses. Thus, reliability and quality of preparing future professionals depend on the level of security in learning management system. The slide presents well-known methods for assessing cybersecurity risk. Analysis of this method was conducted in the publication, including, first, the process for attack simulations and threat analysis, in short, PASTA. This method elevates the threat modeling process to a strategic level by involving key decision makers and requiring security input from operation, governance, architecture, and development. Second model, LINDAN, abbreviation from linkability, identifiability, non-repudiation, detectability, disclosure of information, unawareness, non-compliance. Focuses on privacy concerns and can be used for data security, this method. Third method, fault tree analysis based on the composition undesired event into possible components that led to its occurrence. Fourth method, Octave. Its abbreviation from operationally critical threat, assets, and vulnerability evaluation. This method is a risk-based strategic assessment and planning method for cybersecurity. Analyzed methods do not independently provide a quantitative risk assessment in the form of integrated indicator. Therefore, it was decided to combine a cyber risk assessment model with a multi-criteria decision support method to construct an algorithm for assessing the security against cyber threats in learning management system. The algorithm is based on this utilization of the STRIDE model. The decision to use the STRIDE model was based on its ability to capture the primary cyber threats for assessment, which can be further decomposed into subtypes. The cyber threats identified by STRIDE method can be evaluated through a rating analysis. This means that the severity of impact of each threat can be assessed and assigned a rating based on predefined criteria. By conducting a rating analysis, it becomes possible to prioritize and quantify the level of risk associated with each cyber threat identified by STRIDE method. STRIDE is an abbreviation of spoofing, tampering, repudiation, information disclosed, denial of service, and elevation of privilege. Also, the algorithm is based on the utilization of the TODI multi-criteria decision-making method, the fragment of mathematical apparatus of the method represented on the slide. TODI methods are based on the comparative analysis of alternatives by finding the distances of criterion evaluation by assessing the dominance of alternatives among each other. The TODI method incorporates a coefficient that mitigates the effect of the losses based on prospect theory. This characteristic of the TODI method is an important factor in assessing the risk of cyber threats, as cybersecurity threats are complex and may involve various tools for their realization using different types of vulnerabilities, requiring critical prioritization. A modification of the TODI method was performed to accurately represent the assessment result provided by expert using fuzzy intuitionistic numbers. The modification is presented on the slide. Presented in current publication algorithm of cybersecurity assessment for learning management system is following. A first stage, formation of evaluation criteria set based on STRIDE method. Second stage, selection of expert for assessment. Third stage, assignment of linguistic evaluation by expert for each evaluation criterion. Fourth stage, translation of linguistic variables into number of fuzzy sets. In this research, it was decided to use fuzzy intuitionistic number, which consists of three components that determine the membership, non-membership, and hesitancy of numbers to a set, in our case, to a linguistic set. Fifth stage of algorithm, aggregation of fuzzy evaluation. And sixth stage, determination of the comparative security assessment of learning management system using multiply criteria. The assessment of cybersecurity of learning management system was conducted on the most popular system, namely Edutor, Moodle, and Ilias. This slide presents linguistic variables and their corresponding intuitionistic fuzzy numbers. The slide displayed expert assessment using linguistic variables for each criterion of the STRIDE method in learning management system. This slide displays expert assessment of converted linguistic variables into integer values for each criterion of the STRIDE method in learning management system. According to the obtained result presented in table on the slide, the best alternatives among those studied, according to the expert, are Moodle in second place, Edutor, and Ilias in the last place. It should be noted that assessing the security of learning management system is a complex and challenging task. Experts used both automated software tools and expert evaluation of the system component security, conducted a comprehensive interpretation of the identified vulnerabilities. According to the obtained result, it can be asserted that significant threat to the security of learning management system are cyber risks associated with spoofing, tampering, and elevation of privilege. It is worth noting that some of the analyzed learning management systems require differentiation of system access for teacher and student, as well as the implementation of dual verification, dual system login. Further research. The prospect for further research lies in the development of multi-criteria decision support method to assess risk, considering their prevention. Thank you for your attention.
Thank you for your report. Dear colleagues, please ask your questions, if any.
Good day. My name is Irena Diedic. I'm from Department of Computer Integrated Technologies. Thanks a lot for nice presentation. I have one question. Please tell me, have been the same research conducted abroad?
I Can you repeat the question, because I don't properly understand?
Okay, have been the same research conducted abroad? Maybe you have some experiments.
Not expert only was from our partners that collaborating with our educational institution. This is a private company, and we try to choose the experts that have minimum 3 years of experience, and all the experts was be with from Ukrainian, but that have already experience in cybersecurity scope.
Okay, thank you very much.
Thank you. Maybe another questions? No questions. So thank you for your report. And next report is computer simulation modeling of voice signals in the MATLAB environment for the task of computerized diagnostic systems testing, authored by Leonid Deghi, Oksana Dozorska, Volodymyr Kukuruza, Vyacheslav Nikityuk, and Serhiy Kovaly.
Good day. Let me present a scientific research simulation modeling of voice signals in the MATLAB environment for the task of computerized diagnostic system testing. According to the statistics of the World Health Organization, the number of people with disorders of the human vocal apparatus is increasing every year. Timely diagnosis makes it possible to detect changes in the functional state of the vocal apparatus organs through proper processing of voice signals and to carry out preventive measures or choose a course of treatment. The effectiveness of the functioning of the diagnostic system is determined to a decisive extent by the methods of voice signals processing, which are the basics of the development of such a system software, and must have the means of extracting informative characteristics, signals of changes in the voice apparatus operation. The most informative in terms of medical diagnostics is the selection and processing of a separate class of voice signals. Vocalized fricative sounds are the most sensitive to changes in the functional state of the vocal apparatus organs. However, in order to test the methods of processing to evaluate the reliability of the results of processing vocalized fricative sounds by methods, and accordingly the algorithms and software of diagnosis systems, it is necessary to develop a method of computer simulation modeling of the signal, which would take into account in its structure the main parameters of the medical norm and the pathology of the vocal organs apparatus state, and would make it possible to provide parametric identification on the method of such signals processing in computer diagnosis systems with reliable data reproduction. The process of vocalized fricative sounds creation is shown in Figure 1. Such signal can be represented as a pulse of an amplitude modulated acoustic signal in the form of expression. 1. Pathological changes in the organs of the signal source will be manifested in a change in the time and energy characteristics of the carrier component of signals. Similarly, a dysfunction of the articulation apparatus will be manifested in change in the corresponding characteristic of the invalue component of signal. To determine the time and amplitude characteristics of such components of vocalized fricative sounds, their selection was carried out. Graphs of the envelope component and sample from the carrier component of the signal are shown in Figure 3. At certain intervals, the carrier component of vocalized fricative sounds behaves as a complex mixture of sinusoids, characteristic points, and amplitudes of the carrier component of vocalized fricative sounds within one period are shown in Figure 4. We build a model of the carrier components of vocalized fricative sounds signal in the form of a complex mixture of sinusoids, which takes into account the characteristic points and amplitudes of the signal within the period. Let's reduce the system of equations to one expression. In a similar way, we can write down the expression for the envelope component of vocalized fricative sounds. Then computer simulation of the carrier component of the voice signal was carried out in the MATLAB environment. In Figure 5 shows the sections of the carrier component of real and simulated signals. It can be seen the high degree of similarity of such signals, but the model must take into account the presence of a random component in vocalized fricative sounds, which depends on external and internal factors and forms of pronunciation disorders. In expressions 3 and 4, the amplitudes of the waves and their time durations are constant values. So we introduce a random component into these expressions. Let's combine expressions 5 and 6 into one, which will be the expression of the simulation model of the vocalized fricative sounds. Using expression 5-7, the results of computer simulation of vocalized fricative sounds with different amplitudes and durations within the normal limits were obtained, which were implemented as a program in the MATLAB environment and shown in Figure 6. From Figure 6, it can be seen that the time realizations of the real and simulated signals are similar, and the ratio between the maxima in the power spectral density distributions of these signals called formants is preserved, which indicates the suitability of the developed simulation model for testing computer diagnostic systems. Thank you for your attention.
Okay, and next report is the method and algorithm for detecting the fetal electrocardiographic signal in the presence of interferences. Authored by Galina Francesca, Mykola Хвостівський, Vasil Dozorski, Evgenia Yavorska, and Oleg Zastavny. Please. Galina Francesca is present here. Can you present your work? Oh, yes. I'm sorry, but we can't hear you.
I'm sorry. Let me present you information system for detecting fetal ECG signal in the presence of interference. On this slide, you can see table of contents with such point as introduction, algorithm for extracting fetal ECG signal, generation of fetal ECG signal, detection fetal ECG signal, the adaptive filtering method for mixture of fetal ECG signal, and the results. Congenital heart defects are a significant cause of infant mortality, emphasizing the need of improved diagnosis and treatment. Fetal cardiodiagnostic system can monitor the fetal electrocardial signal, but reliable selection is challenging due to its weak nature and susceptibility to interference. Existing methods for extracting useful fetal ECG signals, such as blind signal separation, synphase and component methods, spectral methods, bispectral processing, and the method based on Neyman-Pearson criteria, have limitation. as they do not consider time frequency characteristic and the phase time parameters simultaneously. Therefore, a new algorithm is proposed to address these issues and provide more reliable results. The algorithm involves several steps. First, maternal ECG signals are registered and filtered to remove noise. Our peaks are then identified using a peak detection algorithm. The second step focuses on detecting fetal ECG signals by analyzing morphological differences and applying low-pass and high-pass filters. If fetal signals are detected, the algorithm proceeds to the third step, which involves adaptive filtering to remove maternal noise and enhance the fetal ECG signal. The filter coefficients are updated in real time based on maternal, fetal, and noise components. Let's move to the generated simulated fetal ECG signal. On this figure, you can see the sampling frequency refers to the number of samples taken per unit time. In this case, a sampling frequency of 1000 Hz was used, meaning the signal was sampled 100,000 times per second. The duration of signal was set to 10 seconds, which is typical length for ECG recordings. The fetal heart rate was set to 140 beats per minute, a common value for a healthy fetus. Next, a maternal ECG signal was generated using a mathematical model that simulates the electrical activity of the maternal heart. Once the maternal ECG signal is generated, a fetal ECG signal is generated by modulating it with a fetal heart rate signal. The fetal heart rate signal is modeled as a sinusoidal signal with the frequencies that corresponds to the fetal heart rate. By multiplying the maternal ECG signal with the sinusoidal signal that corresponds to the fetal heart rate, a simulated fetal ECG signal is generated. To simulate real-world conditions, white Gaussian noise with a signal-to-noise ratio is added to the simulated fetal ECG signal. This noise addition is crucial for creating a more realistic signal resembling actual fetal ECG recordings. The fetal ECG signal in the mother's womb is both periodic due to its physics causes, and stochastic due to the influence of different types of interference, which is why it's mathematically modeled as a periodically correlated stochastic process. The representation of the mixture of fetal and maternal ECG signals as periodically correlated stochastic process in the statement 1 justifies the applicability of well-known statistical analysis method as synphase or component for computing correlation components as indicator of fetal signal detection in the mixture. The observed fetal ECG components are concentrated in specific frequency ranges, while the maternal ECG components occupy a different frequency range. This clear separation of components quantitatively confirms the presence of fetal signal in the mother's uterus, which holds significance for prognostic diagnosis. The adaptive filtering method is commonly used to separate the fetal ECG signal from the mixture of ECG signals. This technique employs adaptive algorithms that continuously update filter coefficients to attenuate unwanted components while preserving the fetal ECG signal. Once the adaptive filtering process is complete, a filtered fetal ECG signal is obtained. This signal primarily consists of the fetal cardiac activity with a reduced level of noise and artifacts. The filtered signal provides a clearer representation of a fetal heartbeat. To accurately analyze the fetal ECG signal, peak detection algorithms are applied to identify the R peaks. These peaks correspond to the fetal heartbeats and provide essential information about the fetal heart rate and rate. In conclusion, extracting the fetal ECG signal from maternal signal is a challenging task, but advancements in signal processing techniques have significantly improved the accuracy and reliability of this process. Further research and development in this field hold great potential for enhancing prenatal care and improving fetal health outcome. Thank you for your attention.
Thank you. Thank you for your report. And dear colleagues, you may ask your questions, if any, please. No questions. So thank you again. And the last our report is IoT-based LPG gas booking and sensor alert system through SMS and email, authored by Vidashi Parashar, Tanya Gradoria, and Vivek Sharma. But they are not present in this meeting. I think the reason of it is the difference in time. They are from India and their time is different from us in Ukraine, from our time. So they'll have a possibility to present their work tomorrow at the final session. Yes, they are not present. So all the reports scheduled for today have been presented. On behalf of all the workshop organizers, I want to thank you for the great work done. I wish you all the best, and this concludes the work of the second day of the workshop. Tomorrow will be the final section of the workshop according to the program. So have a great day, everyone, and stay safe. Goodbye. Thank you.
Thank you. Have a nice day.